What we're going to talk about today is graph powers. And what graph powers are is they are the analog to composing a relation with itself multiple times. So when we say G4, what we're saying is that we'll take its associated relation and we're going to compose it with itself 4 times and see what its result actually is. So what the graph power does is it allows us to kind of create a graphical representation of that composition. Now, we're not very often going to draw out a graph power because it can be really time consuming and very lengthy, and you'll see why in just a moment. Instead, what we're going to do is we're going to generate matrices from the relations of the graphs, and then we're going to use matrix multiplication in order to generate the graph power, because matrix multiplication is really efficient and we can do it with computing power quite easily. But for our purposes and to help us understand graph powers, what I'm going to do is I'm going to draw out some graphs by hand. So a graph power, G sub k, is going to be the set of all walks of length k made up of composing G with itself k times. So what we're going to imagine doing is we're going to go in and we're going to take the walk twice. And so essentially what that means is it's going to look a lot like the composition of relations. And if we don't actually have a walk of length 2, we're not going to include, say for example, a particular vertex or a particular edge. So let's say, for example, I look at here at this graph, G, and it has its edge set here, which is represented by E, which is a relation. Now I go and I'm going to utilize V in this case, my set of vertices, and I'm just going to draw some lines that represent the graph. So I got A to B, right? That's the first edge in the graph. I'll go A to C, and then I'll go C to B, and I'll go D to D. And so you can imagine that this is the first copy of the graph, that first part of the relation. Now what I'm going to do is I'm going to start over here in the second set of vertices. Now you'll notice that we don't have anything going into A. So consequently, on my second set of graphs, I don't need to look at A. I don't have to deal with that. I'll go down to B, and we'll notice that I don't have anything coming out of B inside of the graph either. So consequently, I don't need to deal with B either. Finally, all I have really is C, and we notice that C goes to B. So in my second set of edges, I'm going to have C going to B. And finally, I have D, and D is going to go to D. So you'll notice that we actually do have something going to D from the first set of edges, and now we'll go D to D. Now when I look here, I'm going to have A goes to C goes to B. That actually is a walk of length 2. So I have A to B, that's the first walk that I have inside of my relation, and then I have D to D. So this, by the way, is going to be E squared, or composition of E with itself, that second set of edges. And if we were to draw out the graph, my new graph is going to look like this. I've got A, B, C, and D. So that means I'm going to have A goes to B, and D goes to D. And that's it. And that's the sum total of my composition, and it's actually my graph power for G squared. Let's take a look now at this edge set, or this relation, and its associated graph, which is D right here. And you'll notice that D is a little bit more involved than the last one. And in addition to that, we're going to look to find D3. Now, when we go in to find D3, you'll notice that I actually have my set of vertices where I'm going to start, then I'm going to move to my set of vertices again, I will move again, and I will move again. So in toto, I've got my 3 compositions. So we'll start out, and we have A, we'll notice is going to go to C. And nothing else is going to come out of A. We have no out degree for A other than just that 1. So now we'll go over to B, and we'll notice that B is going to go to C. And now that's the only one coming out of B. So we'll have the next edge, we have C goes to A. We'll notice also that C goes to D, and we'll notice also that D goes to D. Now for our second set of edges, what I want you to notice is I want you to notice that we're not going to include the next edge B going into C because we have nothing that goes to B. So we're just going to start out with A, and we're going to note that again that A goes to C on our graph. Then we'll go to C, and we'll notice that C goes to B, or excuse me, that C goes to A, and that C goes to D, and we'll note that D goes to D. Again, we're going to take a look. We're only going to be coming out of A, C, and D, because those are the only values that we have values going into. And so we'll start with A. We know that A goes to C. We know that C will go to A. And we know that C will go to D. And we know that D will go to D. Now what I'm going to need to do is I'm going to need to go in and I'm going to need to trace the values on my graph and write them in. So I'm going to do this in green, just to help myself out, make it clear. So we're going to start out at A. We notice that A there. So that means that I'm in my set, call it E3 in this case, my edge set 3, I'm going to have A goes to D. Notice that we just drew that path from A to D. Now I will actually take A, C goes to A goes to C, and so that also means that A will go to C as well. Then I will note, okay, I've got A. That pretty much does everything for that second set. So A goes to C, goes to D, goes to D. A goes to C, goes to A, goes to C. That's it. Now we'll go B. So B goes to C, goes to D, goes to D. So that means that we're going to have B to D. We'll note that nothing else. We got B goes to C, goes to D. That's it. That's the only set of graphs that we have there for B. Next, we'll say C goes to A goes to C goes to D. So that means that we're going to have C going to D. Then we'll have, again, C goes to A goes to C goes to A. So we have C goes to A. And then we'll have C goes to D, goes to D, goes to D. But we already have that particular set of edges, or that walk of length 4, or length 3, excuse me. So we don't need to include that one. We already have that walk. So finally, we're going to look at D. We got D goes to D, goes to D, goes to D. So we get D, D as the last walk of length 3. So notice that what we have here in E3 is all the walks of length 3 that we can get from this particular graph D, or this relation E. The relation and the graph are the same thing. We're just kind of representing one, D3 as the graph, and E3 as being the composition of the edge set with itself 3 times. What I want you to notice is I want you to notice that this can be kind of time consuming, it can be a bit confusing, and you have to be really careful as you do it because there's a lot of details going on in here. And so if you're not careful, if you're going through and you're drawing these by hand, it can cause some problems and issues. That's also one of the reasons why matrix multiplication as a representation for graph powers is so handy, and why it'll be a great thing for us to learn that. Now that I've generated my edge set, what I can do is I can go and create my graph. So you notice that I have A goes to D, we'll have A goes to C, B to D, C to D, C to A, and D to D. And that's the graph. All right, a couple things to remember. A graph power, G sub k, is all the walks of length k that we can make up utilizing a graph G. And the idea of a graph power is essentially it's going to be composition of a relation with itself multiple times. In general, we're not going to really want to go out and draw a graph power, but instead we'll utilize matrix multiplication and generating matrices from graphs in order to find our graph powers, because it's a lot more efficient and it actually causes fewer mistakes. For our purposes here, I just wanted to show you what the idea of a graph power is so that as you're going through and doing your own mathematics, it'll allow you to visualize it more effectively. If you like the video, go ahead and click on like. And if you like the channel and you want to learn more about all this different kinds of math, go ahead and hit subscribe.